All right, great. So I'm going to do, let's see, let me also make sure I have the Teams window up so I can see any chat messages. And do feel free to interrupt. There's not a lot of us here. So let's get started. So my name is Jason Van Brackel. I am I work for Rancher Federal, which is a consulting firm in the Kubernetes space that works specifically with Kubernetes and Rancher and all the things that the Rancher Labs team builds. Now, our team, as well as Rancher Labs, was acquired by SUSE earlier this year, so we're all one big happy family again. But we are a separate, like, subsidiary. So, something when I talk about Rancher things, I'm talking about them because I work with them every day, not because I work for Rancher Labs. So I'll make that clear up front. But I'm also the organizer of Kubernetes Philly. So that's the local Kubernetes Meetup. If you'd like to check that out, it's just meetup.com/Kubernetes-Philly. We meet once a month. It's usually like on the second or third Monday or Tuesday. It really just depends on when I can get a speaker. I have a speaker lined up for February. I'm waiting for a confirmation before I put it up because I just got burned for January, where I had 2 speakers lined up and they both got sick the day of the meetup. So that's just kind of it's the winter. We're dealing with the pandemic. People are going to get sick. It's going to happen. But do join the group as well. If you want to get a hold of me after this or any time, I'm always very, very open to helping people out who are learning this stuff. So you can hit me on GitHub, Jason Van Brackel, on Philly Dev Slack, Kubernetes Slack, CNCNF Slack. I'm at JVB. So I'm at JVB in a lot of different places. It makes it easy to find me. I'm on Twitter. Feel free to hit me up on Twitter. I'm not there as often as I used to be because Twitter is a dirty social mess with what happened with the election. So I spend less time there and on Facebook as well. But I'm still out there to help people who need help with this stuff. As well, I have a YouTube channel and a Twitch stream. So which leads me to today. We're going to talk about some Kubernetes with AKS, and you may get a chance to ask questions. And this is the beginning of a conversation around learning Kubernetes, because I will tell you right now, I've been doing this for 5 years. I don't feel like an expert in Kubernetes. It is big, it is complex, and it keeps changing. But it's out here and it isn't going anywhere. So, Kubernetes, it orchestrates containers. That's its only job. Well, sort of. Actually, it does a lot more things now, but it used to just orchestrate containers. Now it'll be able to spin up infrastructure. It has some more features as far as modifying DNS, and there's some other plugins that make it really, really cool to work alongside the cloud. But understand that at its core, its job is just to orchestrate containers throughout your ecosystem. It is very complex. I'm sorry, it just is. But it has to be complex to deal with massive scale. But understand that Kubernetes can be installed on anything from like a Raspberry Pi sized device all the way up to massive data centers. So some of the technologies and some of the companies I'm working with now are installing Kubernetes in the vehicle, on the aircraft, in space. Like these are places Kubernetes is going now on tiny single board computers. So, but it's also well suited to organizing your entire data center. Now, it's complex. We have the reference API. And so Kubernetes is a whole bunch of APIs. Oh, they changed this. Give me a second. Reference API is a whole bunch of APIs. So to know Kubernetes really well, you have to do all these different APIs, and these are all REST APIs. So to manipulate Kubernetes, you're just manipulating REST APIs. So we have everything from container to pod, and we'll talk about what these are in a little while. But understand that everything that we're going to talk about today is just a REST API. It's easy to manipulate. So that's also why it's complex, because to know Kubernetes, well, you have to know all of these. Well, not all of them, but enough of them to be dangerous. So let's talk about what Kubernetes is physically speaking, because it is a bunch of APIs, but it also is physically different types of nodes. This specific diagram is called the Cloud Controller Manager. I just like it because it's a good diagram of what Kubernetes is physically speaking. So there are 2 main node types in Kubernetes, and you could have either 2 node types or 3 node types, depending on how you distribute your system. Now, understand these are conceptual. I can have all of these node types being serviced by one node. So if I have a single board computer running a lightweight Kubernetes distribution, I can have all 3 types of node roles on a single node. So these represent node roles. So first and foremost, we have our worker nodes. That's these light gray boxes here. These represent the actual nodes where your stuff is going to live. So when you deploy things to Kubernetes, they're going to live here. And you can see here we have kubelet and kubeproxy. Kubelet is what talks to the container runtime. So the container runtime is essentially Docker. So in the Windows world, it's Docker. The Linux world, it could be Docker. It could be Containerd. On the Windows world, it will be Containerd soon. Just understand that you have, under the covers, you have a container orchestrator that has a job to talk to the operating system and isolate your applications from one another. That's its job. That's Docker's job. That's Containerd job. Kubelet's job is to talk to that container runtime. Then kubeproxy. It's exactly what it sounds like. It's a network proxy sitting on every one of your servers to make sure that traffic can get to where it needs to be. And we'll talk about why that's important in a little while. Then we have control plane nodes. This is our other type of node. Now we see here down here in the corner etcd. etcd is your database. It's a high-speed key value store that can be distributed into multiple nodes. It can stand alone. It doesn't have to sit alongside all these other Kubernetes things. A matter of fact, a lot of your large data centers do just that. And when I build Kubernetes clusters, and I recommend people build them in the data center, I recommend they actually move these off of the control plane nodes. It really comes down to a fault tolerance versus speed conversation. It's etcd next to the control plane components. Well, it's going to run faster. There's going to be less latency in the connection. The downside is if I lose a control plane node, I'm also losing an etcd node if they live on the same host. So that's the trade-off here. But that control plane node has the API, which is the REST API, which talks to all of these things that I've already mentioned. We have the scheduler, and its job is to figure out where in your cluster things are supposed to go. We have the cloud, we have the controller manager. Everything in Kubernetes is a controller or a control loop. It is the algorithmic embodiment of plan, do, check, act. It quite literally means you make the API call. I'm Kubernetes. I'm going to check the API call you made. I'm going to see if the current state of the cluster is what you asked for. And if not, one of the controllers that's managed by the controller manager is going to make that change on your behalf. So that's really the inside. So I have to understand that architecture, just to understand that's what Kubernetes is doing constantly. It's constantly doing plan, do, check, act. And then etcd, like we said, is our high-speed database. You'll notice here, everything talks to the API. And the API in turn is making calls to various backend components. So you're not looking back here in the database. It's actually designed that way. You look here in the API, and API calls are truth. If it's not in the API, it is not true, even if it's in the database. And let's see, that is Kubernetes physically speaking. Any questions before I move on? All right, I will take the silence as move on, please. So let's do that. But yes, Kubernetes is complex. It is a learning process, and you could be good at Kubernetes without knowing the whole of the thing. Like I don't deal in cluster API. I don't deal in some of the things that go on with, fine-grained tuning of etcd as a database. I have people who do that, who are experts in that, who I lean on. I spend more time on the developer side of this and on helping people stand it up and, start past day one and day two. That's kind of my bread and butter. So why should you care? Well, for developers, we'll talk about developers, operators, and really it's just one. So for developers, containerized applications, you're going to be sticking application containers. The containers become the way we deploy things in distributed systems, breaking the monolith. I know a lot of you built ASP Classic, you built .NET 1, you've got some stuff laying around that's been around for a while. Kubernetes is a great tool to help you slowly morph that monolith into some sort of distributed system. I have another talk on that I do. I'm going to do it this time around. Maybe I'll do one out on Twitch because I think it's a great talk on breaking the monolith. It's a single method of deployment and scale. The container itself is, when you create it, it's immutable. So when you run one, you're running the same thing over and over and over and over again. It makes scale really simple, and it's substrate. So much like in the days where we used to just deploy to VMs or deploy to servers, we knew just enough about the operating system to know what we're talking about as far as talking to Windows or talking to Linux. In this case, Kubernetes becomes our operating system for our distributed systems and for our cloud. For operators, well, they're the ones who are going to run it. and they're going to have to deal with the massive scale. And whether you like it or not, it's not going anywhere. And I say that as I'm really sorry. This is what won, because I've been teaching distributed systems, since the Docker Swarm days, and I'll be 100% honest. Swarm was simpler. It had better user experience, especially for the developer. The problem is it didn't scale. It did a poor job scaling past 15, 20 nodes in the early days. And then as Kubernetes got better and better at scale, it got worse. Mesosphere was a simpler way of doing distributed systems. Nomad is a simple way of doing distributed systems, but they didn't win. And what I mean by that is this was the market share in 2017, and it's only gotten worse. As a matter of fact, the yellow line and the red line have all but disappeared. So in this graph, the red line is Mesosphere, the yellow line is Docker, and the blue line is Kubernetes. And that was interest in mind share at the time in 2017. Those lines are all but gone. As a matter of fact, the red line Mesosphere is now D2IQ, and they're a Kubernetes consulting firm. The yellow line is now Mirantis, who bought Docker Enterprise, and they're also focused on Kubernetes. And this again was 2017. You can see here, Google was still the primary developer, but there's this giant swath of open source independent developers who are contributing to Kubernetes, and the contributions by other major parties like Microsoft have only gotten bigger since then. Matter of fact, Microsoft is a huge contributor to Kubernetes now. They have people on the in the special interest group that help develop the Windows components for Kubernetes and add developers to that project. I know because I hang out there. So let's talk about AKS. AKS is Azure Kubernetes Service. It is highly available. It is managed by Microsoft. The control plane you don't even have to look at, which is kind of nice. And it is backed by an open source project called AKS Engine. And AKS Engine is the open source project that is running AKS. You can actually go take AKS and deploy it in your own data center. I've played around with it a bit. It's not bad. It's actually a pretty nicely put together system. Now, I wouldn't recommend you go do that, because then you're off, running Frankenstein's monster, at least Microsoft's Frankenstein's monster. And I use that in a positive connotation. It's actually a really nice system. Just understand, if you're going to pick it up, you're going to be out on your own, because there aren't a whole ton of organizations running this besides Microsoft. But it's a really cool system. I'll just tell you that from an architectural standpoint, they've done a great job. So why AKS? Again, just so you don't get stuck in your Kubernetes. It starts to manage the things well, so you don't have to, and you can focus on serving your business, meeting business deadlines, and not having to stand up the infrastructure and be an expert at things like etcd. Because etcd just by itself, tuning it is not easy, and be able to constantly monitor it and tune it so it's always at optimal health is not easy. So having a party like Microsoft did for you is worth the money you pay for it. But maybe not. There are times where AKS is not going to be what you want to use. If you want to be in a multi-cluster scenario, AKS is not good for that yet. Hybrid cloud, some on-prem, some in the cloud. Now, AKS can do that. AKS is not going to be managing everything. So we have some, Rancher Labs has some customers where they have AKS in the cloud and RKE, or Rancher's Kubernetes distribution running in their data center, and then Rancher managing both. And that's a thing that we've started doing more often, as we've seen enterprises want this idea of, I want things in my data center, but I also want to have my cloud, my cloud resources, and have them with different permissions and different visibility depending. So you want more control, AKS might not be for you. If you want the latest alpha features, you're not going to want to use AKS. If you're doing that sort of thing. Now, you can take away this Windows features one. That's gotten better just in the last, I'd say, 6 months. So I do this talk every so many months. The Windows features are there now. They weren't there. They went into preview and they weren't quite right. They're really good now, and we'll talk about that as well. And also if the SLA doesn't match. So in the early days of AKS, this SLA was terrible. It was, you're out on your own. Sorry. Fortunately, I think this was back in March of 20. They said, no, this is actually a system that people want, and we're going to back it as being an actual product. But there might be times where, because your legal team is paranoid, or they don't like the availability zones, the guarantee uptimes, they want you to do it yourself. That might be an area where the AKS is not for you. But I've been running AKS and its predecessor ACS now for years. I like it a lot, which is why I teach this. So, any questions before we move on to the next subject? All right, let's keep going then. So, creating an AKS cluster today, we're going to use the Azure Portal because it's just easier to teach that way. Azure CLI makes it nice for GitOps. There's Linux version, there's Windows versions. The Azure CLI is everywhere. ARM templates, they're still a thing. I'm not a huge fan because I like Terraform more because Terraform's multi-platform. But ARM templates, if you're an expert in ARM templates, you can do that too. Terraform is basically infrastructure and configuration as code. It's probably the most popular of those specific projects that's around. They also have enterprise support, but it's completely open source if you just want to use it. That's what I'm doing most of the time. So when I'm doing a Twitch stream on automating all the things, I'm usually doing Terraform. But the one that has really intrigued me over the last, let's say, year is Pulumi. So whereas Terraform created their own language, HCL, to define infrastructure, Pulumi has said, you know what, your developers, we're going to give you an SDK in the language of your choice. So you can define your infrastructure as C#, as JavaScript, as Golang, and then work against your automated infrastructure and you can do unit testing against infrastructure. It's one of those talks. It's like the back of my brain that I want to write and I haven't had time to write. Is doing unit testing for infrastructure as code, and I've been playing around with some different techniques for that. Just with the job that I'm doing now, I'm working on a government project, so I've got a lot more time to think and work in my hands in infrastructure, which is where I'm spending most of my time these days. But Pulumi is also awesome, and then projects like Rancher, so OpenShift, Rancher, Platform 9, Octant, all have ways of talking to different clusters. Rancher is the one that says, you know what, we're not just going to be closed into one company's ecosystem. This will actually spin up AKS, EKS, GKE, and things in air gapped in your own infrastructure, and that is also an open source project. Now we're going to talk about a couple of these APIs because you need to understand a couple of these APIs to start working with Kubernetes. So again, each one of these is going to be represented, by one of these APIs. So if I go to pod, here we are. We're right here on the pod. It has an API representation in JSON or YAML. So when kubectl or the kubectl command line program is talking to Kubernetes, it is doing it through the REST API. Matter of fact, that is the way you talk to Kubernetes, is through that REST API that we talked about here. So everything we're talking about now is we're going to talk about the abstraction that is an API that Kubernetes is doing something under the covers for your behalf. And we're going to go from simple to complex. So we'll start with the pod. The pod is the smallest atomic unit of deployment and scale. Inside of that pod is containers. These containers are co-scheduled, which just means on the same node. They share a network namespace, a file system. They share a container, or did I say a process namespace? These are all Linuxy things. Now, it has a similar type in Windows that's controlled by. So in the Linux world, it's controlled by sections of the Linux kernel that deal with containerization, C groups, and things of that nature. In the Windows world, it's controlled by the host network service and the host container service, so HCS in this case. And you can see here, these are two containers sitting inside of our pod. We have Nginx and we have Redis, web server, high-speed key value store, and one can talk to another directly over localhost because they are co-scheduled and they're in the container. So that pod represents just a set of containers that are in the same space that can talk to each other on localhost. Any questions? All right. Our second abstraction is the replica set. And this too, just to beat the dead horse a little bit, is also an API within Kubernetes. Now, you can see here the warning, create a deployment instead. And we'll talk about deployments in a second. But deployments create replica sets, create pods. So like I said, we're stacking our abstractions. So whereas the pod's job is to manage containers, The Replica Set's job is to manage pods. What I mean by that is really count of pods. So here in this infrastructure, we have 12 pods that we just looked at, our Nginx Redis pods. And let's say I always have a cup of coffee. I'm a caffeine addict, so I'm walking through the data center with my coffee, and I'm klutzy. I've fallen down the steps 4 times this year, and I drop my coffee onto a server rack, and I kill a server. Well, Kubernetes Replica Set's job is to make sure we still have our 12. So as long as there are enough resources in the cluster, you'll still get 12. Now, that being said, if there aren't enough resources to support 12 pods, that being CPU, memory, disk space, things of that nature, Kubernetes will yell at you. It will yell at you in the form of events. It will yell at you in the form of logs. It will emit all of this. But what it will keep trying to do is it will keep trying to do this until it has enough resources to do so, or it hits failure thresholds that you can set. But understand that this is an eventually consistent system. It will eventually get it right, and it will yell at you until it doesn't. And it's one of the powerful things, those control loops, those controllers we talked about, their job is to make sure we eventually get to the state we desire. So deployments. This is what you're going to create most of the time. Now, there are other APIs for creating pods, but deployments is the simplest one for just learning. So a deployment deals with essentially versioning and rollout. So if I'm going from V1 of my container to V2, by default, it will create one new version of my container and spin down one old. Now, for the sake of brevity, I have it doing 2 and 2 in this diagram until it gets to here. But let's say I'm rolling out a new change to a massive infrastructure. I've got 10,000 of these pods that are rolling out, and we notice like 10% of the way in, because you can also set timing mechanisms like every 10 seconds deploy, and we see that 30% rolled out, and we're seeing a weird bug, and so we decide to hit the red button and roll back everything. It can do that. Matter of fact, it can do that to like 15 different versions, which is one of the cool things about deployments. Also, the thing we have to think about as software developers is this scenario, where we might have 2 versions or 3 versions or 5 versions of our APIs, our front ends, our back ends, all living in our infrastructure at the same time. This is both powerful and dangerous. It's powerful because it means we can do small experiments on our customer base to see how a small change might affect. We might target 10% of the customer base that hit our East Coast servers, and see how the system behaves and see how our customers behave. But that also means that our APIs that we develop that service those front-end systems have to be backwards compatible. So there's an architecture discussion there, not just a hardware and infrastructure architecture discussion, but a software architecture discussion and versioning discussions. These are things we have to think about as we move from monolithic systems into large-scale distributed systems. Services. So with those first set of abstractions, we're talking about how we, we're talking about how we deploy things. This is how we expose things. So when you deploy a pod, it is not touchable by the outside world unless you create a service. So the service gives you a DNS entry inside of Kubernetes. So there's a service called Core DNS. Its job is to be DNS for the cluster. So it defines DNS. So the service talks to kubedns, makes sure that we have DNS for inside a pod, so that I don't have to know where that pod is at deploy time. I can call it by its name from one pod to another across different namespaces. When I say namespace in Kubernetes, I mean essentially a cluster within a cluster. So that's the way it's taught in the documentation, is that your namespace is your scoped region for your applications inside of that cluster. Now, you can talk to things across namespaces, but then, inside the pod, I have to talk on localhost. Inside the namespace, I can use the name. Inside of the cluster, I have to use a fully qualified domain name that is the name of my service, the name of my namespace, and like cluster.service.local. So it's a scope difference. And you can also block communication between namespaces, but that's another conversation for a different time. But this gives you an endpoint for a group of pods, regardless of where they live. And there are different types. There are like 5 different types. We're going to talk about really 2 today. The first is a node port. And the way a node port works is the node port is listening on every IP address at the same port. So let's say I've got pods on the second 2 pieces of infrastructure, and my client hits the load balancer. The load balancer sends traffic to this backend server. What happens? The service kicks in and says, "Oh, I don't have any here. I'm going to send traffic over here so you can talk to those." That's really its job. That's all it does. Under the covers, in the Linux world, it's talking to IP tables. In the Windows world, it's talking to the host networking service, the HNS service. So you can actually program against the HNS Verilog. But think of it as routing tables. This is what it is. It's rapidly manipulating the routing tables on your systems so that packets can get where they need to be. So you don't have some network engineer having to manually, fat finger routing rules. The machine fat fingers before you. And then with a load balancer service. So when I create a Kubernetes load balancer, in an AKS system, it creates an Azure load balancer for me. Matter of fact, when we go back to architecture, that's why this thing is important. That is the cloud controller manager that talks to the cloud provider's APIs. So in the Azure world, this is a service principal. So the cloud controller manager has a JSON file that has the information, username, password, all the information about a service principal, and that service principal talks to Azure on your behalf. So if you don't have this configured or it's not configured right, you don't get these load balancer services. They cannot be created, or it will try to create them and it will yell at you because you fat fingered the password. So let the machine do it for you. Then once you hit inside of this boundary, it looks like one of these. So it goes. So when you create a load balancer, you get a node port to go with it, and that load balancer implementation is cloud specific. So the Azure load balancers look different from the AWS, or the AWS load balancers look different from Google's load balancers, look different from DigitalOcean's load balancers, and you can actually do on-prem load balancers with projects like Metal LB. Maybe I'll do a Metal LB talk sometime because that's actually a really cool piece of software. So you might ask, my pods from my infrastructure, how do I send in my web configs and app configs so I don't have 6 different types of my pods? That's config maps and secrets. This actually goes back to 12-factor methodology. So if you're back in the Heroku days or your distributed systems prior to Kubernetes, you might have read this manifesto. And this is an architectural guideline for building distributed systems. Now this predates Kubernetes. It actually predates most containerization, but really it goes back to some of these are obvious, like use source control. Declare your dependencies in a this. I mean, here's the tools: Git, NuGet. This is our configures, our secrets and services, our secrets and config maps. So these are our key value pairs for storing data. This could be an environment variable in your system. This could be a config file. So think web config, app config, Java properties, things of that nature. So we're decoupling our pod from our configuration like this. So everything is YAML. It's the YAML or JSON. Usually when humans are looking at it as YAML. When it goes to Kubernetes, it's usually JSON. So this could be dev, QA, production. Same keys because the web config and app config's name is not going to change from version to version, but what's inside is going to change. So here's this is our key and our value pair. That value might be the contents of the entire file. It could be the certs for our servers, that our web server, so we can validate and do SS or TLS. So that would be a secret, not a config map in that case. The difference between config maps and secrets is encoding. Config maps are plain text. Secrets are not very secret. They're base 64 encoded. If you wanted to learn more about that and how that works and why that works that way, FOSDEM 2019, there's a great talk from Seth Vargo called Base 64 is not encryption, and it talks about how to properly encrypt a Kubernetes cluster. You can see I talk about this a lot. This is a great talk. All that to say, all of the distributions of Kubernetes that are out there like AKS do this for you, which is another reason to use something like AKS. And the on-prem ones like an RKE or KubeADM can do this as well for you. But understand that if you're going to stand one up yourself or you have some developer level cluster, the secrets are not encrypted. They're in base 64 encoded. Important to know. Ingress. So when we talked about services, we were talking about TCP/IP or UDP/IP. So layer 3 and 4 of the OSI model. Ingress is talk to layer 7 or HTTP. So for those unfamiliar with the OSI model, I'm just going to do an OSI model search and find a graphic that I like from images. So the OSI model is a conceptual model on how computers talk to each other. Oh, this is the one I want. So if this is a computer and this is a computer, your representation of data goes from this computer down the stack across the wire or the ether, radio waves, up to the next computer. So this physical layer is like your 802.11 constructs. All your network constructs that say how packets become energy or radio waves go over the wire to another computer. So things that I don't think about ever, that my stepfather used to think about a lot because he's a communication scientist. Layer 3 and 4, this is where we get TCP/IP, UDP/IP, IPX, SPX, back from the Novell days. That's your layer 3 and 4 protocols. Layer 7 is your application layer protocols, HTTP, SMTP, SSH is an application level protocol. So when two computers are talking over HTTP, they're talking over layer 7. So when we're talking services, this is layer 3. This is layer 3 and 4. This all deals with TCP/IP. You see here the IP address and your port. Ingress is dealing layer 7. They deal in HTTP. They deal in services like that. So it's how the traffic gets from outside the cluster to inside the cluster. It's how we expose Kubernetes things to the real world, and allows us to route based on URL, path, host name, things of that nature. And it's not even implemented by Kubernetes itself. It's implemented by some third-party plugin. So in the AKS world, it's being implemented by the Azure load balancer. In the on-prem world, it might be Nginx, it might be HA proxy, it might be an ELB in the Amazon world. So understand that there are different things that actually sits as a standalone component called an ingress controller, and its job is just go from from the load balancer to the ingress controller. Sometimes these things are a combination, back to that layer 4 service. So usually what you'll see is you'll see traffic hit a load balancer. Then it will hit some set of pods or some subset of pods that all they do is run ingress controllers, especially in high traffic scenarios. And the rules for these ingress controllers say, go to this backend service by name, and then the service is configured to go back to these pods. So this is what the big picture traffic looks like. And I'll describe this piece by piece. So the client wants to make a request. It does a DNS lookup. That DNS lookup is probably going to load balancer IP. Now, the reason I put DNS in here is because you can actually customize your system so that every time you create a service or an ingress in Kubernetes, an Azure DNS entry gets created. So there's a separate sub-project called external DNS. Now, I don't believe it's been. I'm not sure if it's been integrated yet into Azure. I haven't got a chance to look at that. I know it's going to be at some point, but it's not that hard to set up. So it's called external DNS, and it lets us automatically create DNS rules. Now it can automate Azure DNS. It can automate Route 53. It can automate all the main cloud providers. It can automate Cloudflare. It can also automate Windows DNS. So you can use internally. So if you're a Windows DNS customer, you can use the RFC client to actually modify Windows DNS on the fly. So then you hit your load balancer. In this case, this is our Azure load balancer. So when I request a load balancer service in Kubernetes, an Azure load balancer is created, and the backends point to ingress controllers. These ingress controllers then take this URL and send it to a service by name, or to the default backend, or just a 404 if things go awry. So we've been talking about the relationship with services and pods. Remember, this is just an abstraction. And these are just abstractions. But the way they connect is via this thing here. So this is a selector. It's a key value pair. So a selector is a query on a label. We've been talking about selectors and labels, but they're important. So labels are the only grouping mechanism in Kubernetes for pods. Matter of fact, labels could go on any API object. So all those APIs that are in the API reference over here can be labeled. So it's actually part of the object metadata. If I were to open the object metadata here, I believe it doesn't even, some of the links don't. It's one of my complaints about the Kubernetes documentation is sometimes the generated documentation is generated from code. It loses things. Just understand that the label is a key value pair. It can be applied to any API object in Kubernetes. The meaning of that label is different depending on the object it's applied to. So when you apply labels to pods, you're grouping those pods. So those labels could be anything. But services have selectors. Those selectors, again, are queries. And so a query on that selector will go to a set of pods by their label. So you could have one service that spreads out traffic to a whole bunch of pods of multiple different versions based on their labels. That's a really powerful paradigm, because it allows us to basically split traffic to specific nodes, split traffic to specific subsets of our population. There's lots of things. I could do an entire talk on deployment methodologies of services and labels in Kubernetes. In fact, I'm going to write that down. Give me 30 seconds to write that down. Service deployment methodologies. So yeah, expect a future talk on that, because I think it's really powerful. I don't think I could touch on enough in a 55-minute talk. So next, we're going to spin up an AKS cluster in the portal, and we're going to talk about some of the things that Azure provides. Before we get there, do we have any questions? I know we've covered so much in 35 minutes, and we're going to cover a lot in the next 20. I'm kind of spraying you down with the fire hose to see how much you can drink at one time. So I've already got a pre-prepped one, because when I need it, because it takes 4 or 5 minutes for these to spin up. I didn't want to waste time, but we are going to duplicate the tab, and we'll show you how to configure what these configurations mean, because we could teach through this as well. So I'm going to pick a Kubernetes service. Now, one thing I do want to point out here in the Kubernetes services, when we go to add a cluster, there is another Kubernetes service out there. It's been deprecated, but you'll still eventually run into its documentation. So we're going to look at AKS, or Azure Kubernetes Service. There was a predecessor called ACS, or Azure Container Service. Understand, Azure Container Service has been deprecated. It used to support Kubernetes, Swarm, and Mesosphere. So Microsoft actually was hedging their bet early on, because nobody knew who was going to win the battle. Matter of fact, Microsoft dumped a bunch of money into Mesosphere to help them build. It's one of the reasons they're still around, even though Mesosphere lost. They had this big pile of money to basically shift into Kubernetes once and become D2IQ. But yeah, Microsoft was involved in that. And I understand why, because Mesosphere was actually easier to use for the developer. But so just know that when you run into documentation, you see ACS, or Azure Container Service, that's the old thing. Move to AKS. I see that less often because it was retired back in January of 2020, but I still run into occasionally. So I'm going to bring it up occasionally on each talk so that people don't stumble over that. So we're going to create a new cluster. Thank you, Azure. All right. Thank you, Portal. I appreciate it. So we're going to go here. We're going to add a Kubernetes cluster. We're going to put it in its own resource group. Live. And the cluster name, we'll just call it live cluster. I'm going to put this in ECUS2. I've already got one over in ECUS1 that I pre-baked. So zones. What this will do is this will split your nodes into availability zones. That way, if a zone goes down or part of your infrastructure becomes unavailable, you have it in availability zones. This was not part of the original thing. This has been the last month or so that this came out, and it's awesome. So you can split it between your zones. Kubernetes version. I'm always going to recommend that you go not maybe to the latest and greatest, but one step back. And the reason now, and that I'm going to say one step back from where Kubernetes is now. So right now they're on 120. 120 is latest, and you're going to want to carefully look at this first jump here, and use this first jump as a stability jump. But understand that this project gets released 3 or 4 times a year. Major releases, big API changes. So minor releases come monthly, but major releases come 3 or 4 times a year, and it's a big deal. So unlike our Windows 7 days, where we stick with the same operating system for 3 or 4 or 5 years, and our enterprises pay for long-term support, and then still pay for support well after the thing is dead, do not do that with Kubernetes. You will shoot yourself in the foot, because the community has promised to give you 3 versions. So 120 is out. It means the community supports 120, 119, 118. That's like a year. It's not even a year now if you're doing 4 releases, which means the community no longer supports this. The documentation on the web no longer supports this. So understand that if you want to be on the same Kubernetes version for 2 years, you're either on your own or you're hiring somebody to help you do that, like a Microsoft. So we're going to go 119. We're going to create. So our primary node pool is just our default node pools. Node pools are groups of nodes that are of the same archetype, essentially. We're going to use D2V2s, enable Linux, but we're going to add another node pool because we always have to have Linux in the world. Our control plane is always going to be Linux, at least for now. There's no such thing as a Windows-only cluster. You can have Windows-only worker node clusters, but as far as the control plane, it needs some Linux. And then we're going to actually enable virtual nodes, and I'm going to add another node pool. Oh, no, wait, it has to be 6. So we're going to call it WinPo. We're going to create OS Windows, and we can do the same thing here and have multi-zone. We're going to need a node size here. Just know that you can't do D1v2. It's too small. I would recommend going no smaller than D2v2 for Windows nodes in general. And this pods per node for Linux nodes, 100 to 110 is a good pod per node density. For Windows, I would put no more than 30 pods on a node. This is a good recommendation. And it has to do with just the maturity of the HNS, the HCS, and the way the networking subsystems work in Windows. You can't pack it as densely as you can with a Linux system right now. That's changing. It used to be like 10. So it's slowly getting at a parity with Linux. But understand, if you're going to adopt Windows nodes, you're taking on some gotchas. Matter of fact, by gotchas, I mean there's an entire document on Kubernetes Windows gotchas. Really, my top is not the Kubernetes document here. Intro to support. So if you're going to support Windows, go read the docs on this and understand that there are limitations. And there's the entire document in the documentation on the limitations, and it's not small. So understand that the Windows world is not as mature as the Linux world. The Linux world has been around for over 5 years now. The Windows world has been about 3, 4 maybe, but it's only been mature for like a year and a half, 2 years. And by mature, I mean still kind of gooey. We had our node pools. We go into our authentication. Now you should use service principals if you're going to be on AKS. That'll let you manipulate your cluster through all of the Azure APIs. I don't do this. I mean, you can do this, but it requires you to take more control. I'm going to use service principal. I'll let it create one for me. Always, always, always turn on RBAC. A Kubernetes cluster without RBAC is wide open to everyone to do everything and to be God on your cluster. Always turn on RBAC. You can also use Active Directory and tie in AD groups to be admins. This is really cool if you're already using Azure Active Directory and if you have backend tie-ins to your own infrastructure. So you can actually start to tie in things in your own infrastructure into your Kubernetes clusters that are in the cloud through Azure AD. Encryption, pick whatever you want there. It's an Azure feature. And then networking. Because we're using Windows nodes, we have to use Azure CNI. So CNI is Container Network Interface. This is the interface or the contract that all the network plugins for Kubernetes decide to do. You can do Kubernetes without a network plugin. It just means you're manually manipulating routing rules. The CNI plugin is what is manipulating IP tables and the host network service for you. You have KubeNet and you have the CNI plugin. We're going to use Azure CNI because we have Windows nodes. It's required in this case. It's also required for virtual nodes. I just clicked the checkbox. I didn't describe what that was. Virtual nodes adds Azure Container Instances, or ACI, as a backing service for Kubernetes. So what that means practically is, like, let's say you get short spikes in traffic. You run out of space on your node, you can redirect and create pods in ACI, and it will be invisible to the cluster. So you got this ACI instances that get created on the fly for you that are faster than spinning up new nodes for Kubernetes to handle short traffic spikes. The payoff in cost is about half an hour. So if you're going to have a spike that's less than half an hour, like a sudden spike, use the virtual nodes backed by ACI. Once you get above half an hour, by and large, it's kind of the rule of thumb. You should start adding more nodes because that's no longer a spike. That's just an uptick in traffic that you have to support for an extended period of time. It's going to cost you more if you use ACI or be above the half an hour. These are minutiae that you don't generally have to worry about. Routing. This is basically your ingress controller for your applications, and it can do DNS. I believe it's DNS zone subscription. So this will actually, this will actually tie this will create the ingress controller for you and tie your DNS zones into your ingress. That whole external DNS thing I was talking about, that they did finish that. So it used to be they just gave you the ingress. It looks like they now give you the ingress and the DNS with it. So that's pretty cool. Like I said, this is every time I do this talk, there are new features in AKS. It's one of the reasons I really love it. They're moving faster than everybody else as far as putting new stuff in. You can do private clusters. So network policy, there are different network plugins. Network policy API allows you to programmatically determine what things can talk to what other things via their namespaces, via their labels, and via their IP blocks. Also via their DNS names. So this allows us to create fine-grained rules in the network policy API, so code. So think of this as firewall as code or micro firewalling at runtime. That's what this does. So Calico, there's Calico, Azure has their own. They have different things. So Calico has its whole own, like it does the Kubernetes network policy, but it also can do fine-grained network policy in like layer 5. Like you can do layer 5 network policy in Calico. It's really powerful. It does some very cool things. It's another open source project that also has like enterprise, pay for variants. Integrations. You can integrate your Azure Monitor and Azure policies into AKS to have consistent policy across all your platform. But understand every time you turn on one of these things as an Azure thing, you're hardwiring into Azure. Like you're saying, I'm an Azure customer for my Kubernetes service, and you are taking on some lock-in. I'm not saying don't take on lock-in. I'm just saying just to understand the choice you're making when you take on that lock-in, like virtual nodes, for example. I think they're really cool. So we're going to review create. It's going to tell me all the things I did wrong. So because usually I screw up something. Oh, I didn't screw up anything this time. And we're going to create. Now, this is kind of nice. This only takes like 4 or 5 minutes. It used to take like 10. But I pre-baked the cluster because, like a good cooking show, we always have the ready-made thing ready for us. And it will do this when it's complete. Now, these links are new. And I love these links because they give you next steps, like connect the cluster, how to integrate automatic deploys to your cluster. So you can actually go in and tie your cluster right in. And see, this is a preview. New things. Every time I do this, you can tie your GitHub into your cluster and create GitHub actions that when you check in code, it spins up, wraps your code into the appropriate YAML, and pushes it to AKS. I'm going to do a talk on this. This is like I started playing with this last night. I'm like, okay, I'm doing a talk on this too. So this is an awesome feature. Bill, I see you're on here. Bill, you're going to get a talk on me for GitHub and Kubernetes tie-ins at some point in the next couple of months. So it's like that's one of those things that's worth it's worth the price of admission. Integrate deployments with automatic deployments in your cluster. So if you don't want to go the route of like doing a Rancher or a Platform 9 or one of these things that visualizes your cluster, the Kubernetes resources are right here within the Azure Portal. So these represent different pods that are running in the kube system namespace. It's like, so kube system namespace is where all the important things about Kubernetes live. Don't touch stuff in here. And when you put stuff in here, understand the stuff in here is usually running as admin. So don't play around in here. You can really break stuff badly and bork your entire cluster. Don't do that. We see our services and ingresses here, and there are already some created, like the Kubernetes API is already exposed. Well, it's not really exposed because I have this locked down. kubedns, this service is the representation for core DNS, that thing that I talked about that keeps the DNS rules for your cluster. We turn on that. We added that ingress add-on. So the ingress has already been set up for us. Metrics server. So pods, your nodes are all emitting different metrics at all times. Have metrics endpoints. Metrics server allows you to scrape those and tie into the Azure monitoring, but also tie into things like Prometheus and Grafana. Again, talks for other days. And then Calico. So Taifa is just one of the versions of Calico that's out there. We can see here our storage. We don't have anything in storage. We have our cluster configuration. And again, this is just our views of the world. These are our config maps. Remember our config maps and secrets? These are just our key value pairs. Like go into my core DNS config map, I can see the actual file. And here, this is just how in this case, our kubedns is configured. I've not played a kubedns, but you can see here, we're already running some sort of Prometheus endpoint inside of here that we just can't see because it's being managed by Azure for us. So we know they're using Prometheus, which is a metrics utility to scrape things for Azure metrics. And of course, we can scale our nodes, and we can do this programmatically through APIs. We can do this with Terraform. We can do this with Azure Resource Manager. We can talk to APIs directly, and we can see here even metrics of our nodes and our clusters. If I I should come up with a good like base metric to show you all just to create one of these, but we're running short on time. We got 5 minutes, and I want to show you how to connect to the cluster so you can do enough to be dangerous. And here we have connect to cluster. So to connect to the cluster, you're gonna go get the Azure CLI. Links right there. You're gonna set it up. You're gonna log in, and you're gonna set your proper subscription. I already have mine set up. We're gonna get credentials. That's important. So I'm gonna show you what that means. So I'm gonna go in. The other thing is go get Windows subsystem for Linux set up and get comfortable with the Linux distribution. All these Kubernetes things are far more comfortable in the Linux world. So I'm gonna go in here, and there are more plugins and tools. And I want, all right, computer. So I'm going to go grab my handy dandy Ubuntu one because that's the one I want. And I'm going to make this a little bit larger because I know not everybody has good eyes. And I'm going to paste that command. So you see here, I'm calling the Azure CLI. What? Oh. Maybe I do need to do that subscription call. Make sure I'm in the right subscription. I was playing with this earlier, and I'm guessing my default is not that. So I'm going to set up my subscription. I'm going to run that. And see here, I'm using AKS. I'm saying get credentials. Now, you're going to need kubectl. Fortunately, AKS also has a subcommand for install CLI. So you can see here, right here, this install CLI. That will get you kubectl, which is the Kubernetes command line thing that it's talking about. So you'll need that as well. What happened when I said, give me give me the credentials, it modified this file. This file is how kubectl and other tools know how to talk to Kubernetes. So let's actually take a look at that for a second. And we're going to just go into less. Okay, so we can see here we have clusters. They're using some sort of cert. So we have the certificate authority sitting in here. So we can do our TLS. We have the server itself, and it has a friendly name. And we can see this. I have multiple clusters in here because I'm dealing with multiple clusters. So what it did for me was it added the cluster to this file. It merged it into here, and it set my current context to pre-bake. So a context is the combination of a user, a namespace, and a cluster. Now you see no namespace here, but you see one up here. All that means is that if my namespace is empty, it's default. So default namespace is the default namespace that comes with Kubernetes. Otherwise, it starts with default and kubesystem, and that's usually it. So I'm in the default namespace. That means I can now do kubectl commands. So it's generally kubectl followed by a verb, followed by an API. So I can see all my nodes. We can also see more about the nodes. See all the nodes, which is a lot of information, or we can get one by name. Oh, I don't have my command line completion on. So let me get my nodes. So I get one by name, and we can now describe one to get more information about it. And we can, yes, I don't have get describe. I have describe, and I want to describe a node. And we see here information about the node. Everything in here is key value pairs. It's YAML. Generally, you're working in pods. Yep. And we can do all namespaces because we're an admin on this system. And I can see here all the things running in this system, and we get statuses about them. You'll spend a lot of time here getting into Kubernetes, but this is where I wanted to get you. I wanted to get to the point where you had a cluster and you could start talking to the cluster and learning more. So next steps, if you want to learn more and get some actually hands-on, I'm going to recommend going in and taking Rancher Academy. It's entirely free. This will not only get you getting on the command line, but this will get you actually setting up a cluster as well, step by step. I helped develop this curriculum when I was with Rancher Labs, along with the Rancher Labs team. So I could say this is worth your time if you want to start getting comfortable in the command line, working with Kubernetes, and securing Kubernetes from a day one, day two perspective. With that, we're just about out of time. So does anybody have any questions for me before we leave here today? And I'll stick around for a couple extra minutes if people have questions. All right. So with that, I will call this a talk. I will put in the slides, and I will put in my brainstorming notes with a whole bunch of links, like all these links I covered today will be on the links for this. So what I'm going to do is I'm going to take this set of slides, and that'll be for yesterday and today because I used a very similar set of slides for both days. And I'll put all of my notes for yesterday and today into a notes markdown file for your use. Feel free to reuse the slides, reteach them, take my name off them, teach others, spread out this information. And again, thanks for your time. Thanks for being with me. If you want to learn more, I'm out on Twitch. I do regular Twitch streams. Well, I did. I'm going to start doing them again for 2021. And you can find me out on Twitch. And I'm JVB. So I'll see you out in the interwebs. And thanks again. Till next time.